Hi friends, welcome back to another session on the operating systems, one concept at a time. Now it is time to see the storage management, that is the place where the programs, data and all are stored when not in use. That's a secondary memory. So mainly we are dealing here with how the secondary memory is managed, or as long as far as primary memory is concerned, we have seen in the previous session, that's main memory management. Now let's jump into how the secondary memory and others are managed. So the storage management system consists of the processes and the techniques used to efficiently manage how the data is stored and accessed on a computer's storage devices. There are many different devices. So there are many different types of memory associated with any computer system. So let's first get into what they are. The innermost one that's nearest to the CPU is the registers. These registers are directly connected to the CPU and they are part of the central processing unit, the chip, and they are designed. The connectivity are designed with high precision, so they will be working at processor speed. Then next thing comes is the cache memory. The registers are very limited in number, so to make sure that process is speeded up, we need some more memory, and that memory, and due to the reduction in size of the processors due to advancement in the VLSI technology, more and more space was available, and this space was utilized by adding memory into the chip itself, and that was called cache memory. And this cache memory is inside the processor chip and hence will be working at a higher speed, at almost processor speed. So the whatever space was available, that much of memory was created inside the chip, and if that is not sufficient, then we get out of the chip and we go on to the motherboard, and on the motherboard we have memory called the random access memory, and this has no space problem, and hence we have a more space available for the data to be stored. So we have a higher amount of memory available here, that's on the motherboard, which we call the main memory, and that's what we had seen in the previous session about the main memory management. Since this is put on the motherboard, it's not very well designed, so it will be working almost 1,000 times slower than the main processor. And the next one is the electronic disk, usually called pen drives and all that, which are plug and play type of memory we have, and these also are an electronic memory, so there won't be any more moving parts and all that, so they will also be working at a higher rate. But only thing is they have to interact with the IO ports, and IO ports usually work in the serial mode of communication, and hence to transmit one byte of data, it should be transmitted in 8 time slots, because each time slot one bit of data is being transferred. So it will be a little slower compared to the main memory. Then we have a requirement of more memory, then we get into what we call a magnetic disk. That's a hard drive, and this hard drive has got a larger capacity, but the magnetic disk is being used through movement, rotations, and all that, and it's having mechanical movements, and hence is quite slower compared to the electronic memory. And the next one is the optical disc, which makes use of optical, the laser rays and all that, and that will again needs mechanical movement, and hence it is also slower, but can have more amount of data in a given space because it is working at the light dimensions. And finally, we have a bulk memory which is stored in terms of magnetic tapes. So magnetic tape is the slowest memory, registers are the fastest memory. So there are so many various types of memory. So here we are not bothered about registers, cache, and main memory. We are only bothered from the electronic disk, magnetic disk, optical disk, or magnetic tapes like things. Most commonly, we are talking about the magnetic disk type of memory in this case, and then look at how individual entity of the data is stored onto that, and it's all that taken care. So when working under storage management, we need to look at how the memory is managed, how the disk is managed, how the files are managed, and how the free space is managed. So these are the various components of the storage management. In the previous session, we have seen about the memory management. Now this is time to look at what the disk management and file management are. So file management is the one which handles the organization, storage, access, and control of files. So how the files are organized on the disk and how it is stored, how it is accessed, and how the files are controlled so that it is protected from misuse and all that. So the file management also provides a logical view of files, hiding the physical storage details. So we are not interested in where each component of the file is stored and all that, as we were discussing in earlier stage, that the space may not be available at one place, so it can be put in various different places. So we are not bothered about where the data is placed in the memory and how it is placed and all that. We are only bothered about if I want a amount of data to be written or retrieved and all that. I just want to use a name for that instead of going through all the details. So it gives an abstraction, it hides all the working details of how the data is stored inside the memory and all that. It makes no sense to us to know all these informations. What is important to us is name of the file and want to read or write or modify or whatever you are talking. So that's so just we work on a logical level, and at the physical level what actually happens is taken care by the file management component of the operating system. It manages the file attributes like names of the file, types of the file, size of the file, and the permissions. All these things are taken care by the file management. And coming to the disk management, that means we are talking about how physically things are stored onto the secondary memory. So it organizes and maintains the data on storage devices like hard drives and SSDs. It includes partitioning, formatting, managing the file system, and all that. So it's not just a one particular entity, it is divided into partitions to make the things simpler, because we have to make sure that the mechanical movements are done as minimum as possible, so that the overall process is speeded up, and what is the format of the with which the data is stored and all that, everything has to be taken care. This is done in the disk management system, and also ensures that data integrity and efficient storage space utilization. So these all are the various components of the disk management system of operating system. So let's just have a little um, extra information about the file system. So file basically is a logical storage unit which consists of data and the attributes. So here we can see that the user is having its own application that gets into the logical file system. Logical file system works with a virtual file system. Virtual file system works with the physical file system, and finally the data is put onto the storage. So as a user, we don't have to worry about all internal details. We just have to talk about what is the name of the file and what we want to do with that file, want to open it or write it or modify it or delete it, create it. All these operations we are only bothered about. And internally, what all things are happening is none of our business. We don't want to waste our time on all that, and these all activities we just give it to our file system. And then these files for our quick reference and all are maintained hierarchically in the tree format under the directory structure, so that we can easily understand where our file is. Instead of having all things dumped at one place, we can just logically divide them into directories, and in each directory we can have different files and all that, directory, subdirectory, and so on. So it's a logically tree structure is created, so that will help us in arranging the files in a more better way, more understandable, easily placed and easily retrievable, and all that is possible. Then the various operations possible, the file operations, we can create a file, we can open a file, we can read a file, we can write onto the file, we can delete a file, we can close a file, truncate the file, flush, wire, write lines, change across permission and all that. So these are various operations that are possible with the file. So we want to create a file, so we use the create function. So when you want to interact with the contents of the file, the first thing we have to do is open the file, and when the file is opened, only then we can work on that. So to make sure that the file is opened, we the one who is opening should have all the permissions and all that. So this all things are taken care. So these are the various examples of the file systems. It may be NTFC or FAT32 and all that. So some details we are going to look in the coming sessions when we deal with this file system in detail. Now coming to the other part, where the data is physically how they are managed onto the secondary device, which we call disk management. The figure here shows how hard disk can be arranged. So it's made up of many disks which are rotated through a spindle, and each disk will have tracks, and each track consists of sectors. So we have a cylinder, then we have a sector. So for that particular cylinder, we have one track on each of the what you say platter or the disk. Then we have an ARM assembly to which read-write heads are connected, and these read-write heads move in and out so that different track can be used, and to use a particular sector, this whole thing is rotated. So when this is rotated, a different sector comes near the read-write head, and maybe a magnetic or optical way the reading writing can be done, and that's the whole concept of the disk arrangement. So it is made up of tracks, sectors, cylinders, and so on. So to make sure that a particular data is to be read, then we must ensure which of the disk we are trying to look at, where our data is, on which disk, on which track, and which sector. So disk, we need to activate appropriate read-write head, and then track. Then this ARM assembly should move in and out so that appropriate track can be used, and then for correct sector, the whole system is rotated so that that particular sector comes near the read write head, and the read or write activity continues. Now there are scheduling, because we just want to make sure that the data is put on disk, and we are not sure that the whole file can be written at one segment or one sector or one track. So it may be placed at various locations depending on the free space available. So it's not necessary that every part of the file may be on the same disk or on the same track or on the same sector. So it may be possible. So to make sure that everything is read properly, then this movement of the heads and movement of the disk should be done in such a way that with minimum movements we would be able to complete all the tasks. So that is what we call the scheduling algorithm, and we have various scheduling algorithms for disk management to make sure that the various components of the file are read from the disk at the earliest with minimum movements, because movement means it needs time, there is inertia, and movement, mechanical movement is very slow compared to the electronic speed. The processor speed is in nanoseconds, and movements and all, if we consider, then they will be working in millisecond speed. That means 1 is to million slowdown is there. So if you want to ensure that the whole process is fast, then we need to make sure that these mechanical movements are made as minimum as possible, and that is taken care by these scheduling algorithms. And then we need to look at the what we have, what we call is random disk for performance and reliability. We look at how to improve the performance of the read write activity of the disk. So these are various issues we need to look at when we are working with the backend or the secondary storage. So more details to come. So please keep watching. Thank you.